try to make it accessible to you, regardless of whether you're actually here in class every day or not. I want you to be here every day, but if you are not for whatever reason, the lectures are going to be available. They'll be posted on YouTube. Also, if you are here and you want to review what was talked about in class, it'll still be there. So if while you're in class, something's really complex, instead of spending your time trying to scribble something down, sit back, relax, think. I know that sometimes if you're trying to write something really fast, you can get distracted and miss something else that goes on. So feel free to, you don't have to be writing or typing or something at all points in time in here. I'd like you to be paying attention whatever way works best for you. If that's jotting a few notes and then going back and filling them in later, if that's writing everything down, if that's writing nothing down, but the lectures will be available later. I screen record all of this and the audio from the classroom so that you can kind of recreate having been in class or be in class again if you aren't, or if you want to see it again. So in any case, as I said, this class was designed to kind of be a better introduction to calculus than what's typically happened in calculus courses around the country. But I want to give you a little perspective based on comparing mathematics learning in the US versus other countries, and also comparing it to other calculus classes. How many of you have been in a calculus course before? Yeah, a lot of you? Okay, so that's a good sign, but I also want to let you know that you might not be doing, it's not going to be like the exact same thing again, unless, well, maybe if you're repeating this class from last semester. It's probably going to be a little bit different from what you experienced before in calculus courses, because it is a different set of curriculum. It's the same topic, it's calculus, but we're going to focus on some other pieces of the curriculum to make it more meaningful for you going forward. So some comparisons with what goes on in other countries. So we have some survey data from 1975 and 2000. This is 1975 data regarding number of, as you can see, number of 24-year-olds, so a percent here per 100 24-year-olds that had science and engineering degrees in the 1970s, this blue graphs here. So this looks like a weird list order here. They're not in alphabetical order, not in increasing order. There's a reason for that. It has to do with the second part of this graph. But you can see between 1 and 5% for all these different countries. You've got countries like, smaller countries like Lithuania, larger countries like China and the US. But in 1975, a lot different from today in terms of technological needs, immediately speaking. That was when the kind of ramp up began into technology. Like in 1975, I definitely would not have been projecting this on the screen from my laptop using the Wi-Fi system in the classroom. We have the stuff underneath, probably a blackboard instead, actually. There's a lot of changes just in user end technology that we've had, but a lot of science and engineering has exploded since the 1970s. So we'd expect a lot more people, percentage-wise, have math degrees and science degrees in all these different countries. So you can see from all those 0 to 5% of 24-year-olds have math and science degrees, some of these did explode. Taiwan went from like about 4% to 18%. Or the UK from about 3% to 11%. If you can see, the US went from about 4 to 5.5% or so. Not a huge change. And the US is a huge country, so percentage-wise, that's not a large increase. It's a lot more people. But percentage-wise still, I mean, regardless of the size of your country, if suddenly 3 times as many people are getting degrees in math and science than they used to, well, not suddenly, it's over a period of 25 years there. And a lot more has changed since 2000 also. We don't have the next round of data on this yet. But in any case, you can see that there's been great increases, but some places had a much larger percentage increase than others. And again, part of it is due, obviously, to the size of the country and those sorts of things. But there are some larger countries that also had great increases, like Australia. Australia didn't even make the chart in the first one. It was close to 0. Now we've got over 10%. And Australia is quite a large country. Well, it's large physically, but it's got a large population. France and the UK are not small countries. They've got millions and millions of people. And they're smaller geographically speaking, but to have, nearly triple the number of people with math and science degrees, whereas there's not quite such a change here. It's like, well, why? So the why is part of it, but the be aware of this is also another part of it. And you're all in this because you're in working in something where you're working towards a math or science degree. So you've made it to the part where you started this. I want to make sure you finish it, that you finish it successfully, and that you get something out of it, not just like, ugh, finally done with that class. Because depending on how you approach all of the classes, not just this one, but depending on how you approach all of your classes, you can get something out of them or you can just kind of pass through. But the difference is, eventually you want to get hired by somebody proving that you know something. And, if you don't really know things, you can maybe fake it for a little while. I want to make sure you don't, have to fake anything. But going back to why there's maybe these differences, earlier in your education, everybody's had different sets of experiences in K through 12, or whatever equivalent pre-college education is if you're not from here. But TIMS, it's like a science and technology study. They videotaped 100 randomly selected 8th grade classrooms in Germany, Japan, and the US. So we're looking to see what's going on in 8th grade. I don't know if you remember your 8th grade classroom. Mine tended to be a little bit disorganized, crazy people throwing stuff every once in a while. Not very interesting, sitting there learning the same stuff it seems like we learned for a while. But so taking a look at these lessons, these researchers were looking for what were the quality of activities that the teachers were putting together for their students and what were the students doing in class. So I have a chart here where we looked at whether there are high quality activities, medium quality, low quality. So low quality activity for a teacher doing something might be like, here, have a worksheet, do this stuff. And it's like a bunch of multiplication table, something simple, not very interesting. That'd be like low quality, low effort, low meaningfulness for students. Just like, do some stuff, I'll talk to you later. Medium quality might be like, all right, let's sit and work on some story problems, maybe in some groups. High quality might be something along the lines of, okay, so let's research, let's find some data and, plot some things that you locate. You get the idea, kind of like more complex tasks, or maybe more you have to come up with what you need to find on your own. So just between low, medium, and high quality sorts of instruction things. When they looked at Germany, they say, okay, so it's about fairly evenly spread between, and this was researchers, like I said, it's like in 100 different classrooms throughout all these different countries, and just kind of looking at what was going on. So it's fairly evenly spread between, like you have to do some rote practice of things every once in a while. And then you've got some other slightly more interesting, more challenging sorts of activities to do in class to help you learn. So when they looked at Japan, here's what they found. The results of their study were, it was much more concentrated in the middle, fewer of the low-end activities, a little bit more of the high to make up for that, much more in the middle, like a lot of kind of challenging sorts of questions, maybe not, the medium is maybe not the find your own research sort of question, but there's a bit more than that, there's less of the low-end variety. So thinking about your experiences, if you're from the US, in 8th grade math, anyone want to have a guess what % of the time it was high quality activities going on in US 8th grade classrooms? 6. I think those are all a little bit too high. Yeah. So, I mean, you made it through, so that's good. Despite this, I mean, you might very well have been some of the lucky ones, not these classrooms. These are randomly selected. There are certainly great teachers around the US that helped probably a lot of you get to where you are. But that's just not the norm. That's not usually what happens in this country. For whatever variety of reasons related to how the schools are set up and everything else, you can see that this is randomly selected 8th grade classrooms. It wasn't like they tried to pick teachers who were doing a bad job or something. But education in the US is not necessarily quite going the same direction as it is in other countries, especially in that preparation for college, like when you're ramping up from elementary school, getting ready to go to secondary school, you have to take all these specific classes to get into the college you want in that. So the point of this is that what might be seen as good or normal instruction in the United States is not necessarily good when compared to what's going on in other countries, in the sense of what these researchers are looking for, which is not like they know all the answers to every questions and what they say is the only way that you can do this, but they were trying to find what are good learning activities, what helps students to progress, and they weren't seeing that for the most part when they were in the US classrooms in 8th grade. So the intent of this class is to not be 8th grade math, but to try to incorporate some more of those high-end activities. So maybe you've seen some more of those since, like whenever. You probably did some really cool stuff in elementary school. Elementary school teachers are really good at like, here's some things, try to figure out how to solve these story problems by like, take these egg crates and some dice and throw them in the air and figure something out. That kind of goes away for a while because everybody becomes bratty when they're 12. I don't know. But in any case, I want to make this class something where you learn something new, where you understand what's going on, where you are helping to create an understanding for yourself of what calculus is, how it can be useful. Because when you go to a workplace, they don't give you worksheets, say, here, can you finish these problems for me? That's not really a thing unless you're like a textbook editor and you're writing the solutions for a very boring worksheet. That's not really a job that people have. So the point of calculus then, there are some complicated procedures we can do, but those aren't what we're going to focus on. Because, I don't know how many of you saw that movie Hidden Figures? Anyone? Yeah. So the one woman in there, her job title was literally computer. And then when they actually got a physical, electronic computer, they had her double checking the output of the computer to make sure that they programmed it right. That doesn't really happen anymore. You don't get to have a job where you double check the computer in that sense. We double check the programmers, but somebody has to do the programming. We want you to like create the things that do the computations that we want, but somebody has to know what computations we want and why. So there are computer programs that are well set up. If you want to just answer, like, what's the derivative of, such and such ugly formula? Or what's the antiderivative of, something? You can type in any bizarre expression into Wolfram Alpha, or the program that we're going to use in class. It's called GC. I'll tell you a little bit more about that in a little bit. GC is short for graphing calculator, but it's not just a graphing calculator. That's just the name of the program. It does graph and it does lots of other things as well, including it's a program where you can like save files and send them and stuff. But our goal is not to just work on performing procedures, like do an operation. I don't want this class to be just the advanced version of here's a worksheet, do all these addition problems as fast as you can. That's not our point. The purpose is that, back a while ago, we needed people to do that sort of stuff, and they were fastest at it. Whether it was like that Hidden Figures movie, or like the people in the back of the bombers in World War II doing trig really fast to calculate wind speed and stuff. We don't do that anymore. There's computers that take care of all that. That's basic programming that people have done long ago, and maybe there'll be some way to make the programming more efficient or update the mechanisms inside the chips. But in the past, that's what we needed people to do, and that's how calculus courses and textbooks were designed. But that's not what we need really anymore. We don't need you to be able to do a bunch of derivatives really fast, because a computer's always going to be faster than you. We don't need you to be able to sketch something to like a beautiful degree of accuracy, because there's graphic programs that can do that, and they're all set up. That's not the complex procedures that I want your brain to focus on. So, as you can see here, so most of the people using calculus in the past were given some functions, some equations, told to do some stuff with them, and the people up above them were the ones that came up with the here's what we need to analyze. Well, we don't need the lower level anymore. The lower level has been taken over by computers. So we need you to be the upper level, the person who decides what needs to be analyzed and how, what sort of functions and equations are appropriate, because computers can't make those sorts of decisions, at least not yet. Some, yes, but for the most part, what I want you to be able to do is read a situation of some sort. Some scenario is laid out. and understand what the relationship is between some of the quantities in the problem, how they're related, how changes in one affect change in another, and what that means over time, or whatever the sorts of constraints of the problem may be. But you're going to have to figure out what needs to be done, as opposed to somebody telling you, here, do this, like take the derivative of all of these. It's going to be, we're going to have a lot more open-ended sorts of questions where you're given a starting point, and then you have to figure out how to use the facts that we've learned, how they apply in this situation in order to move forward. So, in other words, people that use calculus today in their jobs are more like the manager usage, the upper tier of what used to happen in the past, because the lower tier has been replaced by technology. We don't need the rote computation aspect of this anymore. So although we're going to do some of that, you need to understand how it works. That's not going to be the main focus of the class. We're not going to spend half the class here practice these computations. It's going to be more about solving problems, trying to get from end to end, and constructing calculus, the theory of it all from ourselves, for ourselves. So we are not going to be doing these things. Memorizing a whole bunch of random things. There's going to be a component of the class where we have to memorize. Just at some point in time, you have to kind of know your times tables, at least more or less, so you can get through going on to something else without always having to look something up. But that's going to be like a couple of weeks, and that's about it. Replicating examples and procedures. Yes, there are certain types of problems, but every problem is going to have some differences to it from ones you encountered in the past, which is why we do, why we think about these, to practice. Okay, so what if this changes? What do I need to do differently now? And in examining more of those, like how changes in given information or known information affects how you have to approach something, or being just aware of those changes so that you can start to formulate ideas on what could I maybe do that would help me get past this, because this isn't like what I saw before. This is something slightly different. So there isn't going to be a lot of, like I said, memorization or like repeat like 17 problems that are all the same with just some different numbers. Or just like, all right, I'm going to put this number here and do this and that, and then there's my answer, circle it, done. That's not very helpful. And although, at certain points there are some things that you need to memorize, we're now in college, and I don't want this to seem like an 8th grade class. I don't want this to seem like just a boring, do the same thing all the time. I want to make it more useful for you. So even if you had calculus before, whether it was here or in high school or something, I want this to be like a bigger calculus course for you, to go deeper into it. Just like you had history in 3rd grade, but if you take a history class now, it's not going to be the same thing. Your history professors in college would expect a lot more of you than your 3rd grade teacher would. Same thing here. I want to expect more from you, and I want you to expect more from yourself than maybe you would have or your teacher would have in a high school level calculus course, even if it was AP, because there's different sorts of aspects that AP calculus focuses on. I'm not saying that like that's a bad class program or anything. It's just like they're focused on their specific sets of topics, and we're doing something slightly different. So I also don't want you to try to guess what I want you to say, like in an answer. Like you don't have to have a key magic word in order for it to be the right answer. Just there's a lot of different ways to explain the same concepts, or to get to answers. There's a lot of different routes that you can use. So what I want you to do is understand what on earth calculus is, what all these ideas have to do with one another, and all the relationships between quantities that we'll be dealing with, different things that are measurable. That's what I mean by quantities. And then seeing this not just as, okay, here's unit 1, we did this, here's unit 2, we did this, here's unit 3, we did this, but see how we have a set of topics that go together and it blends into and connects to what we move on to next. So we will have multiple tests, and the first test covers a set of topics, but the second test covers all of those and then some, because they're all related. It's not just, okay, now we're doing something different that's not related. It's all related. That's why we call it one class. And in fact, I hope that multiple math classes after this are all also related to what we learn in here. So the idea is there's something called the fundamental theorem of calculus that relates all of the concepts that we're going to be working with throughout this semester. And then we're going to start talking about this fundamental theorem of calculus within a few weeks or so. We have to get past some kind of introductory parts but then we're going to start to put together what is this overall overarching idea related to essentially rates of change and accumulation. So those are, if I know how much of something I have at any point in time, I should be able to also say at what rate that is changing at any point in time, and vice versa. If I know at what rate something is changing, like how fast I'm driving, I should be able to say how far I've driven over any interval of time that I'm given. So this rates and accumulation are like how rates make something happen, what happens because of a rate of change, or vice versa. Again, like if I know how much of something I have and that amount is changing, how do I measure the rates, those rates of change of that amount, of that quantity? So that's all encompassed in this fundamental theorem of calculus, which in some calculus courses is kind of like a, oh, and here, by the way, is some statement, poof, and you don't use it for anything. That was pretty much my experience even with AP Calculus in high school, and like, oh, that's kind of weird. Didn't really understand what it was about until I took calculus again in college. And I hope that you have a good experience here. It's very often people take calculus in both high school and college because it's a different experience. But also, when you have you want to be well prepared for college, but at the same hand, your major, they'd like you to have a specific version of calculus that's taught at the college that you are. So there's also that. I know your advisors, even if you had AP credit, often will say something like, yeah, but you should probably just take it so that you are well prepared, or so that you know how we do calculus here, or what your professors will be expecting from you in your major. So as I was saying, we're not going to just do a whole bunch of problems that are the same thing over and over again. So a common reaction might be when you're looking at an assignment, whether it's something to do in here in recitation or on your own in homework, is that I've never done one like this before. Don't let that worry you. That's good. It's not that it's going to be a mystery and you're going to have to research for multiple hours, but just that that's what I want you to spend time thinking about. How do I creatively apply the ideas that we used, the tools and building blocks, if you will, to approach slightly new problems, ones that aren't quite like what we've seen before. What is it that's different, and how can I adapt to that change? So this requires that you understand what you're doing, not just have a set. First I'm going to put this number here, and then I'm going to take a derivative, and then I'm going to subtract something and set it to 0. And you need to know what you're doing and why, not just the some steps to follow. So a set of steps to follow can get you so far if you have similar problems repeatedly, but if your problems vary some, then you're going to have to understand, well, let's see, this isn't like the last one, so how do I adjust? What do I need to change about my approach? Like, how is this going to be reflected? Because this isn't quite the same, so is the same step going to work or not? So really understanding what you're doing when you're going through a procedure to finish a problem, or whatever you want to call it, rather than just saying, all right, I have these 6 steps, I do them every time, and that's the end, because that would mean you had a whole bunch of very boring problems. And also, in the homework, I also hope that the problems that you're asked to complete help you put together the ideas we've talked. So it's not just like, we learned everything and you're perfect at it, and then you can just show me with these beautiful problems at the end. I hope that the process of actually doing the homework helps you to put together the ideas or solidify them, because sometimes there's a lot of details, and when you work through some problems, you go, oh, that's why this, whatever we said in class one day, some aha moment while you're working on your homework, or it helps you understand what the difference between a couple of examples we did in class were. So be aware that at various points in time you will be asked to explain why or what it is that you did. So just be ready for that. Not just because this is like something we did in class, because it probably won't be. So make sure that you can explain what it is that you did and why what you were doing will help to solve the problem. Again, just the process of trying to write down why you did what you did can help you find mistakes if you made them, but can also help gel in your mind what all of the meanings were for the steps that you were using, or what the relationship was between some of the pieces that were involved in the problem you were solving. So I'll talk about office hours in a minute, but we will have office hours, a variety of them available through not just, well, I'll have some office hours, Julia and Frank will have office hours, but there's another lecture of this class also that meets later in the afternoon, and the instructor and recitation leaders for that class also have office hours. You're welcome to go to any of those, and there's hours in the tutoring center. Come to office hours, ask questions, not just like the how do I get the answer to this problem, but make sure you're thinking about like what is the underlying, like why do I not know how to approach this? What is it about this that's confusing? So you're welcome to ask, like, how do I do this problem? But we're probably not just going to tell you the answer, oh, just subtract 7 and divide by square root of pi. It's not going to be something like that. We'll probably ask you to explain what you did, why you were doing it, and help you through it. So we want to get you in that mindset of we're working on this together. We're not like the experts that are just going to like throw answers at you. We want to help you understand it so that you can then, going into your next class, be well prepared for that. Going into your classes that are more in your major, if you're not a math major, so that you understand how what you learned in here is actually useful, why they made you take this. I don't want it to just be some random requirement that you're getting out of the way. I want it to be helpful as they hoped it would be helpful. So, in any case, this is not necessarily easy stuff to do. There's a lot of work involved in this, but the idea is that we'll pay off for you. This will be good, be good for you. Sounds like it's like oatmeal or something. But I hope that this helps you kind of, whether it's change your idea about what mathematics is or about what learning in general should be like. If that happens, then great, I'm happy. But at least, though, I want you to understand what calculus is about by the time we're done with this semester. All right, so that said, let me show you a little bit about the Canvas website. So our class is not on Blackboard, it's on Canvas, which you can navigate to from My ASU by clicking on the course title, or you can just go to canvas.asu.edu. And in Canvas, you won't see MAT251, that's just me, but you will see this MAT270. I don't know if how it is. Yeah, I was gonna say, so I have, you can customize the title that shows up for you. I just customize this for me so I don't get it confused with my other classes that show up. But you'll see something that says MAT270, and it could be any color. It doesn't have to be blue even. But the insides look the same regardless of what the outsides look like. Oh, by the way, you're welcome, I encourage using computers in here, as long as you're on something course related like Canvas or any of our class websites, or taking notes or something, perfectly fine. So, make this look less messy. All right, so other than the pink border here, when you go to Canvas, it should look something like this. And you'll see an announcement at the top that has some instructions on some of the programs, which again, I'll get to in a minute. But there's a link to the course syllabus, a link to the textbook, which is free, and it's online. It's not in, there's no physical paper form of it because the book is full of animations, things that move, like videos and stuff to play, and if you put that on paper, it doesn't work so well. There's a link here to all the lecture videos. Now, right now there's none, but as soon as I can get the video to process after class today, today's will be posted there just so you can test it out, make sure you can get to them. Probably not the one that you're going to need to review the most. There's also a link to where our online homework is going to be. Most of your homework in here is going to be online. There'll be some written work as well. There'll be written work that you submit in recitation, and there'll be occasionally written work that we'll submit in here also. But most of your work is done through this iMathAS, which is also free. And then we've got office hours here. So let me just pull up office hours since we were mentioning that just a minute ago. So office hours, here we go. So there are a bunch of different people who are available to assist with office hours. So the three of us in here, I don't have any hours listed on here because I'm only going to be here kind of intermittently, but feel free to email me especially if you can't find anyone, I might be around. But you can see there's hours a little bit on Monday, quite a few on Tuesday, a lot on Wednesday, kind of between our two lectures, and some more on Thursday and Friday. So this is some people, I believe there's going to be some more added.
Yeah, Eric hasn't. So there's also tutors in the Math Tutoring Center that have taken this course before and are now tutors for this course, but I don't have their schedule yet. As soon as they do, I'll update it on here so that you guys will know when they work there too.
Yeah, and they tend to be more in the afternoon area, so there'll probably be some more added down below that. But in the Math Tutor Center, Wexler 116 is where you'll find,
Everyone's except for Hedwig.
yeah, the ones in blue here. No, half of the ones in blue here. These Tuesday and Thursday, 10:30 to 12, are in the ECA building, and the rest of these are all in Wexler 116, which is, we're at the opposite. Wexler is also called PSA in some things. We're currently in PSH. It's just the, let's see, what direction are we? The other end of the, away from the bridge, the other end of this building. And there's like a little coffee shop plaza sort of area if you haven't been in that tutor center before. So in any case, office hours, there's a lot of them through the week because you can go see anybody. We're all working on, between the two lectures, we're working on the same material. We meet together weekly so we know what everybody's doing to make sure we're all on the same pace. So if you say, I was working on the stuff in the iMath AS homework, everyone will know what you're working on because everybody's doing the same problems. Let's see. So let me go back to the beginning. All right, oh, so this announcement says, welcome to MAT270 plus GC download instructions. GC is, as I said before, it's a graphing calculator. It's a free program for you to download. It's not free for the general public, but we have, there's instructions here that are in your textbook with the download links, but the registration information that you need so that you can get into it for free are in this announcement. It's just, we have special permission from the authors who work with the author of the textbook to have this program used in our class because it's really quite cool. But the section 1.0 of the textbook has a course download link. Here, I'll just click on it. Here's the book. This is Newton Meets Technology. But in any case, scrolling down through here, section 1.0 is installing graphing calculator. So if you go there, there's instructions for Macs and for PCs. You can't do this on a Chromebook because, as you know, your Chromebook just kind of runs apps through the internet, and this is not one of those. If you do have a Chromebook or something other than Windows or Mac, there are computers on campus that have this installed, some of which are in the Math Tutoring Center and some of which are in the Computing Commons that are near the bookstore. So you aren't stuck, but you just won't be able to use it in class. So if you do have a Windows or Mac laptop, I would suggest installing GC on that so that you can bring it with you to lecture and recitation and use it. So we'll be doing some sorts of, like during class, we'll be talking about some certain problem. I'll ask you to try something, use GC, see if you can get it to do, you know, show this graph, generate an equation that does this, whatever it might be. And so we'll be doing some activities using GC in class. So if you have it on a laptop, that's more useful. If you have in recitation, you'll be often doing some activities there as well that use this. If you don't have a laptop that you can use or don't have a Windows or PC laptop, you can look on with someone else. You're not going to be docked grade points for not having a laptop of a specific type. It's just, if you have that, it's useful. You can bring it to class and recitation, and please feel free to use it. And that's where I would suggest installing this program. So let me show you this GC program. So it looks very boring when you open it up. It's like, oh great, it's a square window. But so this is a command line. If I type something like y equals 2x plus 1, it'll graph a line for me. Great. So I can do that on any graphing calculator. It can do lots of other things besides graphing. You can solve equations with it. There's some tips and tricks inside the Canvas show. You'll see some like keyboard shortcuts to do things like get a new command line like this. But those also all appear in these menus up above. So I'm like, what do I do? Show keypad. I want to get a new something or another. So you can look through those menus up there. But there's lots of keyboard shortcuts that are on a one page front and back PDF documents that are listed in the Canvas shell. And you'll talk about those in recitation on Friday. So if I wanted to do something, like it can do numerical computations too, like I can do 3 times, and then just using the regular time sign over the 8. If I type pi for pi, I type p, shows up as that. When I type the I, it turns into a pi button. So I can do quick computations like that. Divided by e to the 15th power. And one nice thing about this is, now it looks kind of strange because it gave me parentheses, but you can copy and paste things. So if you wrote some big, long, ugly expression up above and you need to use it again, you can use it again later. So I'm going to copy and paste that. So like just the Control C, or just, you can do the regular off the edit menu sorts of things. So you can paste them again. So it's kind of nice in that sense. It's more like using a computer program than using a graphing calculator that hasn't been updated since 1990. It's got some nice features to it. Now there are some similarities between this and, like, Desmos. If you've used online calculators before, it does some of the same things as that, but it also has the programming ability. Let's see, do I have one of those easily accessible? Let's see. Let me just find in here. A lot of the animations that are in this textbook, most of them are from GC. Like, are they all? I was gonna say, I thought there were a couple that weren't. But let's see. There's sections in here that talk about how GC draws graphs and things like that. But what am I looking for? Here we go. So this is like chapter 5. We'll be here in a couple of months. But this is using GC. This is just putting little text notations in to make it look pretty. But this is just that program we were using with a lot of programming built in, so it can animate things. There's an animation bar down below where you can make it change things, but this will be more meaningful later. But all of this was just done in that program. And for instance, let's see. Let's see, what do I want to do? Y equals n. So n in GC makes a slider bar show up. And I just type y equals n. So if n is 0, that's y equals 0. If n is 1, then y equals 1. And here's a little slider down here that lets me change the value of n. Now notice this is a green horizontal line. You might not be able to see that. These bars, you can change their colors. Now I'm going to make it black and a blue. But when n gets smaller or larger, let me scoot this up. If you can see this at the bottom, this is n going from, I don't know, 0 to something. I'm going to zoom this out a little bit. Zoom in and zoom out is pretty easy too. But if I push play, let's just make something move on the screen. So the point of making things move is like, oh, that's cool, now we have a moving picture. As I talked about earlier, one of the main focuses of calculus is to figure out how rate of change affects accumulation, and how from an amount that we know that's changing over time, how I can determine a rate of change. Well, if you have rates of change, something needs to be changing. So if you want to visualize change occurring, it's nicer to have moving pictures than a stagnant, like all the way done graph. So for instance, if I wanted to take my y equals 2x plus 1, and instead of having it just be this line, let me get rid of some of this other stuff so it's not a mess. So if I want this to be more moving, I can say, well, I'm going to put a domain restriction on this. I'm going to let x go between 0 and n, and then I'm going to let n change. So 0 through, let's see, x is between 0 and n. I'm only going to graph this line, like algebra 1 or pre-algebra sort of thing to graph, between 0 and n, and then I let n move. Let's see. There we go. So now I can make a moving line, or a line that's extending, or I can think about something changing. So thinking about change, say, oh, well, you know a lot about slope, right? Slope, if I have a slope of 2, that means like 2 to 1. When y, when x increases by 1, y increases by 2. Or when x increases by 5, y increases by 10. Or when x increases by anything, y increases by 2 times as much. This is a constant rate of change. One of our first topics of the class is going to be to talk about what's meant by a constant rate of change. Well, linear equations model constant rates of change. But it doesn't just come in increments of integer chunks. X doesn't have to change by, like, go over 1 up 2, over 1 up 2. That'll help you sketch something the way that people sketch things. But the way that computers sketch things is, well, anytime x changes by a little bit, y changes by twice as much. X could change by 0.007. while changed by 2 times 0.007. Those changes in the independent and dependent variable of the x and the y are in this relationship based on this constant rate of 2, a 2-to-1 ratio. Now, there's no story to go along with this one, but regardless, this represents a constant rate of change, and we can see something actually changing by making the graph move like this instead of just having, here's a line. There's nothing changing if you have a full line there. Like, oh, what's the rate of change? Nothing's changing, so nothing. So in terms of that, that's part of why we like this program, because it does allow you to animate graphs and show change occurring, because change occurring is how something accumulates, whether this is time going by and height above the ground of something, or this is population increase, and this is like a, I don't know, uncomfortableness factor. Who knows? Whatever this might be a graph of, we can make things, even just a simple like linear graph, we can make it slightly more interesting or meaningful or related to what we're working on if we, play around with it a little. So you'll learn a lot of tricks related to GC. It's not really like a programming language per se. It's more or less just typing math. So you get to type things that you've seen in math books. Y equals 2x plus 1 between 0 and, well, what's n? Well, n's down here. Right now it's 8.2. So we'll talk about these parameters. This n is something that I allow to change values through this, but it's just talking about a particular endpoint. It's representing the endpoint of this line, open endpoint in this case. But in any case, GC is kind of cool. Like I said, you'll learn about it a little bit more and some tips and tricks and some activities you'll be doing in class on recitation on Friday. But let's see, back to here. So in the announcements, let's see. It mentioned the downloading GC. The instructions are in section 1.0 of the book for Mac and Windows both. And the code that you need, the registration information, the name is Arizona State, and the serial number is this lovely thing, which you can copy and paste. The homework for the class is also online and free. So I have you all set up in the class as of, well, I'll update it to reflect people that have added the class in the last few days. I think there are a few people. But in any case, your username when you go to this website is just your ASU, right? So usually your first initial and some or all of your last name, maybe some numbers. Everybody's password is the same right now because I had to make a password for you, and it had to have all these symbols and numbers and stuff in it. So I just made it as simple as I could with all those. Newton 1, 2, 3, and then the symbols that are over 1, 2, 3 by hitting shift. But you can change your password to something else so that I don't break in and make all your homework answers wrong. But in any case, let's see. If you click here, this will take you to the homework. There's a link to this iMathAS also from the main page of Canvas. You don't have to go into the announcements all the time. You'll see something like this, only it'll say courses you're taking at the top, not courses you're teaching. And when you go in, it should look something like this. And you'll see that there are some assignments on this calendar that are upcoming due. For instance, tomorrow, there's a homework assignment that's due. Is it related to math? Not very much. It's related to understanding iMathAS and making sure that you can log into this website. So the nice thing about this calendar is not only do you have a visual of when your assignments on here are due, but when you click on them, you'll see underneath the calendar, there's a link to it. So you don't have to like go hunting. Where is this homework 1? Where is it hidden? Now, it is just in this module 1 assignments here, along with some other things that aren't due yet. But you can go directly to this homework number 1, which is due 11:59 p.m. tomorrow. And it's just basically some, have you logged into the system with instructions from Canvas? Yes. You can answer no if you want, but I would suggest saying yes. Might as well get the easy questions right. Some of the questions are like, just practice at typing things in and using some of the symbols. So this is asking for true and false. This is asking you to evaluate. It says, notice it's 2 over 3 minus 3. If it doesn't evaluate to a number, type undefined. So this is, learning how to type undefined, I guess. But just, there's different sorts of ways that questions are answered. Some of them are letter answers. Some of them are numerical answers. Some of them are formula type answers. And some are multiple choice or matching sorts of questions. So this is just kind of a tutorial for getting through iMathAS and making sure that you can actually get into the system in the first place. So I'll double check that everybody's name is already in there, but if you're registered as of like Thursday last week, I know your name's in here. I think I added a couple more since then, but I'll double check to make sure everybody's name is in here, in which case you should just be able to, you don't have to do anything fancy like have any course ID numbers, just type your ASU right ID and that weird password that was in the announcement, that Newton123 symbol, and you should be in. And just click on the course name and you'll see the assignment calendar, it'll look like this. And so there's a bunch of assignments that are in here that'll be due later in the semester. Please don't work on them all in advance because on some of them there are things like, you only get like 2 tries until it starts deducting points if you get them wrong. So I'd suggest, wait until later. But the instructions like that are listed at the beginning of the assignment. In any case, there's homework. You can see there's stuff due in the next few weeks that's listed. The rest of the assignments will be posted with deadlines once it's a little bit closer. So in any case, this is where the online homework is. Let's see. That's the textbook. Go back to here. So back to Canvas. I want to talk about the syllabus a little bit. I hope that you had a chance to take a look at the syllabus. It is on here. Let's see, loading. It has contact information on it, how your grade is determined, when our tests are, a schedule of like topics and so forth, more or less. Every once in a while, just based on discussions in class, things might take more or less time a little bit. But the general setup of how this class is going to be run is all in here. So you've got the catalog description, things that you need. Nothing are things that you need to pay for other than a laptop if you want to have one with you in class, and printer. If you don't necessarily have to have your own printer, but occasionally there'll be some like print out this work, the stuff from GC or whatever occasionally. There are printers on campus. It's not like we're going to ask you to print out 50 pages of this and that and you have to pay a lot. So please don't go buy a printer in order to cover this, but just realize there are printers on campus that you have access to, and for 5 cents per page, 8 cents per page, it's not very much. But if you need to print out some things, there are emergency printers here in addition to like anybody else that you might know that has a printer that would let you use it. Let's see. The only days where we're missing class is spring break, like the Monday holidays. We're not meeting on Mondays, but there's spring break at the beginning of March, and that is it. So, yeah, the rest is just Monday is Martin Luther King Day in a couple of weeks, and we've got spring break, and the rest of these are withdrawal deadline sorts of informations. A month before the end of the semester is when if you want to withdraw from an individual class, that's about a month before the end of the semester. If you're going to drop all your classes, you have till the last day to do that. But I hope that neither of those is something that you're considering at this point. Grade-wise, homework, the online homework stuff and other assignments that you do in recitation, although it's very important for you, it is 10% of your grade. Your grade comes more from other sorts of assignments, but those will help you prepare. There's going to be 2 sorts of quizzes in here. Written quizzes that we do either in class or sometimes as take-homes. And then online quizzes, which are through Canvas, and I'll show you one of those in a little bit. There are 3 regular sorts of exams for our class that cover like the content from lecture. They're all multiple choice Scantron sorts of tests, not based on computation. It's based on understanding like which of these is the correct expression to describe blah, blah, blah. So we'll talk more about that as the tests get closer, and we've actually talked about math in here. But there are 3 regular sort of tests. Those are 10% each of your grade. There's also a derivative mastery exam, which takes place in the evening, and I have that date on the next page of the syllabus. But derivative mastery exam is not multiple choice Scantron. It is do some derivatives, and that's the part of the class that's the rote memorization part. It's kind of boring, but we'll spend a couple weeks on it after spring break, and then you'll study on your own to make sure you've got all these rules down and practice, and then we'll have that mastery exam will be a couple weeks later than when we stop talking about them as just our main focus of class and are just using them. So that'll be in end of March, I believe, start of April, actually, I believe. And the final exam is cumulative. It's multiple choice Scantron like the other class tests where it's 25% of your grade. But let's see. Here's the schedule. So course schedule, you'll see here the highlighted items in blue, those are the tests. So they're about 4 weeks apart each. So our first test is at the end of January, second test is at the end of February. The mastery test is at the start of April, although it's in the evening, not during class. And then the third regular test, is near the end of April. The final exam is the last day of April. It's 1 week after the final test in here. Now, I don't know, the final exams, if you have been around, are not necessarily in the regular classroom. We have a uniform final exam times. It's a 7 to 9 p.m. class. They'll let me know what the room is sometime in March, or they'll let Julia know what the room is sometime in March. But in any case, just be aware that there are 2 times when you're going to be doing tests in the evening. One is the final exam, and that's Tuesday, April 30th, and the other is a mastery test. It's not evening, but like afternoon and evening. More details on that as it gets a little bit closer. Also have to look, the location of that will be to be announced, but it's going to be on a Wednesday, not during class, but over several hour periods, so that you have a window of time in case you have a class during then or something. You can make arrangements in advance, because that's 3 months from now, just about. So in any case, the descriptions after that are about what your homework is like, how you do that, what the quizzes are like. Like I said, there's 2 sorts of quizzes: online quizzes through Canvas, which are free to take, but you just have to remember to do them. And then written quizzes, which are done either in here or sometimes as take-homes over the weekend, between Tuesday and Thursday. It just kind of depends. But the written ones, as opposed to the online ones, are worth a significantly larger portion of your grade. Have between 8 and 10 of them during the course of the semester, just depending on how time works. There's descriptions of the 3 tests, the mastery exam and the final, and about attendance and participation. Attendance isn't taken every day, but kind of expect that you be here. So there's a lot of things that, although you can catch up on the lecture later, there's things we might talk, or an opportunity to ask questions that you won't have if you're not here. And so make sure you're here, make sure you're on time. I realize that there's weird traffic in the mornings sometimes, and it's kind of hard to predict how long it'll take to get here. Don't project that if you live normally 5 minutes away, it'll only take you 5 minutes to get here. It'll probably be 30, because that's how life works. Especially on test day, make sure you leave early so that you don't miss the start of a test due to weird traffic. Rest of this, just watch technology stuff in class. If you want to use laptops, that's great, as long as you're doing mathy sorts of things and not like having fun on Facebook, YouTube, whatever it might be. Please read the syllabus, all the specifics of that. I don't want to spend all of our time going through this, but let's see, back to other things. So you'll see these links over here, these quizzes here. This isn't all of the quizzes. This is Canvas quizzes. So if you click on that, there's 1 quiz that I believe is available already. There's 2 of them. Nope, this one we do. All right. What is today? 10th. So there's Canvas quiz number 1, the course intro. You'll see these here. These are both things that are upcoming. This one says not available until January 10th, and then it's due January 10th at 9:10 a.m. So this will be like it'll show up, and you're going to do this at the start of class on Thursday. This math experience survey is something, it's just like after the dropout deadline is passed, so it's just the people that are actually going to be here for sure. This is something by the math department that they would like us to answer, like I was saying earlier. People had lots of different experiences in previous math classes. In general, in 8th grade, U.S. education, not so good, but I don't want to know about your 8th grade experience and see if it was 0% high quality learning activities. I want to know what it is that you've been doing more recently, just so you get kind of an idea of what your background is coming into this course. So this math experience survey, there's some questions in there. There's also an opportunity to submit yourself for participating in paid research throughout the semester later. So please do that survey, and you can read about what all opportunities there are there. But that'll appear next week, Monday. There are going to be graded quizzes. So this is surveys. These are not, there's no right or wrong answers really to this. Well, they're kind of right or wrong answers to that, but it's not really part of your grade. It's just, please do these. There will be graded quizzes that appear at the top intermittently throughout the semester. Those will be related to, they might be really quick, like 5-minute quizzes, just answer a couple things maybe in class. But more often, probably like after class, just do it before the end of the day. sort of short-ish quizzes. Some might take a little bit longer, but these are timed quizzes. Not worth a huge chunk of your grade, but generally meant to see, like, did you understand what we were talking about the last couple of days in class? Not highly detailed, but just some kind of short answers, like which of these expressions correctly represents such and such problem, like pick multiple choice sorts of answers. Let's see, other things I wanted to point out on this website. So just moving downward through this page, this introductory information is all the general stuff. If you need to get to the syllabus, the class text, the homework site, lecture videos, all that stuff's right at the top for you, and it'll be there all semester. Other information, so daily sorts of things to do, homework, will be listed here. It's not all necessarily written homework, but so this is this week, and it'll be published with information briefly. It's not, actually I think I already made it available. Sorry, I'm in this student view. I can't tell normally what I've done to it. But after each lecture, you'll have something updated here to show you what you need to do before the next class. Some of them have deadlines that are prior to that. So like for instance, there might be on a, like after a Tuesday class, there might be something that you need to finish by the end of Tuesday that you probably knew about earlier, but just as a reminder, hey, finish this by tonight at midnight. Make sure you read such and such chapter. So for instance, let's click on this. So this Canvas quiz number 1, I don't know if I have that set to the right date right now. Is that, yeah, Thursday. So by 11:59 Thursday to verify your attendance. We've been changing this stuff around. Let's see, completing iMath.AS homework number 1 by Wednesday night. And you saw that was on the calendar listed with red. Oh, by the way, on the iMath.AS, those, let me just click here. These color codes don't mean like what type of assignment they are. Red means it's due really soon. This one is just in yellow because, well, it's extra credit. But this means it's due soon. If it's in red, the green is farther off, yellow is kind of in between. Different sorts of assignments have different different color emergencies for them. But just red means it's due pretty soon, so pay attention, please do this. So that iMath.AS homework number 1, answer entry sorts of stuff, that's due by tomorrow night. Install GC before lecture on Thursday. We're going to play around with that together. I'm going to have some things for us to try to do, try to get GC to do, just some brief things. And then on Friday in recitation, you'll be doing some more. So just make sure you have it tomorrow, and we can, or not tomorrow, Thursday. And if you're having trouble getting it installed correctly or having trouble typing things in, we'll all be here to help you. So it'll be kind of a wander around, make sure this technology is working properly. But if you want to try it out at home, see if you can do something like we did today, just some basic, type in some things and see what happens. Play around with it, you can't mess it up. It's just a computer program, you can always shut it down and not save anything, and then you open it up and it's fresh to start again. Let's see, oh, and textbook before Thursday, because we will actually end Thursday, in addition to playing around with GC, we're actually going to be doing some math. We're going to be talking about constant rate of change, which is section 1.5 in the textbook. If you look at the text, chapters 1 and 2, for the most part, we're not going to talk too much about those. Chapter 1 starts with installing GC and some kind of technical details and background on the textbook and stuff like that. Chapter 2 is a review of trigonometry, which we'll touch a little bit on some more of that later in the semester. But we're going to talk about section 1.5, which is about constant rate of change, and then go into chapter 3, which is where the meat of the course begins. So chapters, well, section 1.5 plus chapters 3 and 4 are essentially what's covered on your first test, which is at the end of this month. So don't worry about the fact that, oh my gosh, we're skipping the first 3 sections. We're not really skipping stuff. We're skipping things that are review information. If you would like to look through them, please do. It won't hurt you. But read through section 1.5 and the preface to the textbook. If you do want to look at sections 1.1 through 1.4, it's about extremely large and small numbers and their relationship to one another, and just like how to deal with extremely large and small quantities when you've got things possibly in scientific notation, or like if I want to know if I stack up $2 million bills on top of one another and each one is 0.0014 inches thick, like how thick is that, or like how many would I have to stack to make it be a mile high? Just dealing with like the relationship between large and small numbers. The reason for this is Well, when we're talking about rates of change and accumulating things, we're going to accumulate a little tiny bit at a time. But if you have extremely small bits you're accumulating and you like mass together millions and millions and millions of them, eventually you can get to a large amount of accumulation despite looking at little incremental tiny bits at a time. So this is related to what we're talking about, but we're just not going to spend class time on those sections. But there's some interesting problems in there, like figuring out how many grains of sand there are in the Sahara Desert. So
That's your extra credit in IMath.
yeah.
So
yeah.
It's optional, but it's also your extra credit in IMath. So
yeah.
I would read it if you want help for your extra credit.
Yes. So in any case, these assignments there will be listed in this, just on the main homepage here. Home just takes you back to this view here where the recent announcements would show at the top, and then you'll have the basic course information, and then any handouts that you get in class would be posted here. So sometimes in class, hand out some things, they'll be posted somewhere or another. If it's like in lecture, it might be just posted with your homework. Here's something that we got in class today in case you missed it. Finish this up before class on Thursday. So if you miss a piece of paper in class, it's not the end of the world because those pieces of paper were all electronically generated documents anyway, so they can be found on Canvas somewhere or another. All right, let's see. So other things so far, recitation documents here will be a list of things that you get in recitation so that you can, like, I'm looking for, you're going to get a lot of documents electronically or otherwise in class just to kind of keep them separated from where would this maybe be located. This separate section of things you might get in recitation are here. There's two things that you're going to get in class on Friday. Actually, are we passing out paper copies or? Yeah, okay. But depending on whether you have a Mac or a PC, some of the shortcuts, the keyboard shortcuts are slightly different for GC. Some of them vary by what operating system version you're on, but all of them can be found somehow or another. There's no one that's stuck not able to do these, but for instance, let me open this up. The GC Mac handout tells you how, if I want to draw a graph, if I want to zoom in or zoom out, if I want to get a fourth root sign, if I need a new command line, if I want to make a slider. So there's all these like tips and tricks for how to do this. And the things that you do the most often, you're going to remember how to do them or just take a couple guesses like, oh yeah, it was R, not V or something. Some error issues and how to resolve them are on the back side of this. How to understand what it's talking about. And it's like, I don't know what this means. Error, unexpected something, like, well, some of those are on the back side of this. So in any case, these you'll be doing with an activity in class, in recitation on Friday, with whatever version of it you might need. But let's see. All these things will be available as we go through the semester. The module 2, I just kind of called them modules because that's what Canvas calls them, but module 2 after test 1, this is the stuff related to test 2, we'll have some information there starting from end of January through end of February and so forth through this. And but that last week of class, if you remember I said that test 3 is just a week before the final exam, and it's it's in class the next to last day of class. So that just that last day of class is kind of a sum up of everything that we've done for the whole semester. Some of the day prior to the test, the previous Thursday, would also be just kind of a sum up of like how everything from the whole semester relates to one another. And so that's what the summary is, just some final exam information. But you'll see all of this throughout the semester, and it'll appear throughout the semester. If you have any questions, please let somebody know. We don't want you to go through not knowing how to find the information that you need. So anybody have any general questions right now? No? We're good? All right, then let's call it a day for today. Make sure that before the end of tomorrow, you do that IMath AS introductory assignment, and I will fix that announcement that I had in there. All right.